Hi, and welcome back to another lecture. We are covering section 2.5, which is formulas and problem solving. So what we're going to do today is we're going to look at our first problem here, which is a formula. So we are looking at this beautiful equation. And as you can see through this beautiful equation, we have a lot of variables. So that's the primary difference really between just an equation where you're solving for a variable and a formula. A formula typically have multiple input values. And so this could be dimensions of a trapezoid, for example, which is what you have on the board behind me. So in this particular formula, following along in my notes, it says given A is equal to 1/2 h times the quantity of capital B plus lowercase b, and you know that you have A is equal to 180, capital B is equal to 11, and little b, lowercase b, is 7. Find h. So a couple different ways that you can approach this problem, but we're going to go ahead, since we have the values, let's just plug those in and see what we get. So I have A is equal to 180. I don't know h because it wasn't given to me. Capital B is 11. Lowercase b is 7. All right, let's combine some like terms here. So I have 180 is equal to 1/2 h. This is 18. Now, at this stage, I would actually take 1/2 of 18. You can multiply in any order, so it is not fixed. Like addition, you must add left to right. Multiplication, you should also do left to right. However, if all of your terms are multiplied, you can rearrange those terms. So for example, just to go off on a little tangent, side note if you will, if I have 3 terms A, B, C, and they're all multiplied, this is the same as B times A times C, or the same as C times B times A, and so on. You get the idea. I can rearrange my terms for multiplication. And so that's exactly what I'm going to do in this problem here. So I'm going to have 1/2 times 18. Well, what's half of 18? 9. So I have 9h on this side. My 180 has not yet changed. Solving for h, I'm going to divide by 9 to both sides. So I get h alone. 180 divided by 9 is 20. There we go. Now, in our problem, it does say just find h. There we are. Excellent. Let's try another problem. We're going to step it up just a little bit. So I do need board space first. The next problem, I'm going to get the formula up here first. But it says, excuse me, for the next problem it says solve the formula for t. So it wants a specific value. What you're actually seeing in this particular formula is essentially simple interest, including your principal, and that gives you a total amount value. So you have your A for amount, P for principal, your rate is your interest rate, and the time that you are investing. This is simple interest only. Now, that being said, we are solving for t. Sometimes, just as a reminder, it kind of helps to note what you're solving for off to the side. Just a little easy tip there. So I am solving for t. First things first, I have to find out where t is in my problem. It only occurs in one location, which means everything else needs to move. So I have this p all by itself right now. It's currently, it's a positive value p. There's no sign out here. So I'm going to currently, from adding, subtract it over, and that makes it a minus p is equal to PRT. Now, given this, I again have multiplication here. So I have P times R times T. I'm going to divide out my PR, both terms, from both sides. Those cancel completely. I'm left with time only on this side. Put that a little higher. And this side is done. Leave it as is. It doesn't simplify. So I have a minus p divided by pr. Done. Now, with the same problem, there is one other thing that I want to show you. And that's because in terms of formulas, sometimes you may see a little bit of a variation in how it is solved. So I'm going to go back to my original problem for just a moment. So I have a is equal to p plus pr, that's a pr, t. Solving for t still, so this is, if you think of it like this is method 1, this is method 2. It's not really a different method, but it's a slight variation. As I'm solving, again, I have to move that p over, so I have a minus p is equal to prt. What you may notice some people do, and this is true in textbooks, it's true in just practice, it just depends. But what they may do is they may divide each term by what this value is. In this case, it's PR. So we're going to divide each term on both sides by PR. That is perfectly fine if that's what you want to do, but your end result will look a little different, albeit a little more complicated than what we had before. In this case, I have A over PR minus, in this case, my P's technically could cancel because it's P over P. And so this is 1 minus 1 over R is equal to my time. So all in all, these are exactly the same, even though they look a little different. And the reason that they are exactly the same is because you chose a slightly different method for simplifying. It is my suggestion to keep things as simple as possible whenever possible. And so in this instance, I divided by the PR to the entire section of A minus P. And that gave me a little bit of a rational expression here, and that's perfectly fine. This is something that as you're doing a formula, you can input the values very easily, like we did in our last problem. Okay, let's move into the next problem. Of course, I do need board space. And just so you know, the next problem is a word problem. So you will want the notes in front of you. That way you have the text available. Okay, the word problem is, if the length of a rectangular parking lot is 10 meters less than twice its width, and the perimeter is 400 meters, find the length of the parking lot. Word problem strategies. Let it hit you in the face like a baseball bat, and now let's dive back into it. If the length of a rectangular parking lot, I can draw that. I'm fairly good at rectangles too. All right, beautiful. I somehow still messed up my rectangle. Don't laugh at me. Fortunately, it's an empty classroom as I'm doing my lecture. All right, so the judgment can be recorded. All right, here is my rectangular parking lot. Beautiful. If the length of a rectangular parking lot is 10 meters less than twice its width. Hold the phone. I got length. I've got width. Perfect. If the length of a rectangular parking lot is 10 meters less than twice its width, I don't know what the width is. It didn't tell me. But I know the length is going to be 10 meters less than twice its width. So the length is 2w minus 10. And the perimeter is 400 meters. So the perimeter is 400 meters. What is perimeter? Perimeter is the outside measure of an object, of a polygon. So in this particular polygon, this rectangle, my perimeter, if I were to add all sides together, is 400 meters. Okay. Perimeter is 400 meters. Find the length of the parking lot. Okay. Now, in this instance, you have to put a little bit of work into it beforehand to really get a good understanding of what you're looking at mathematically. So talking about perimeter, we just said it was the addition of all sides. So you could do this manually, or you could say that I have two lengths and I have two widths. So I have two lengths and I have two widths. So if I were to add all of my sides up, this is what I would come out to as a perimeter formula. Notice I have multiple variables. That is A-OK. I do know my perimeter is 400 meters. So I can plug that in. I also know something about the length. The length is 2w minus 10. So I can substitute that value for length. Because my length is equal to 2w minus 10, I can take this value and replace it for L, giving me 2 times my length there. Don't forget this width at the end of your perimeter statement. It didn't go anywhere. So I do know a few things, and it kind of helped me out. Now look at my problem. Everything is in one variable, just the width. Very good. Now let's simplify. I don't see any fractions or decimals, so we can go ahead and just distribute. The 400 didn't change. This becomes 4w minus 20 plus 2w. Moving my 20 over, that's 420, is equal to 6w. Divide by 6, that gives you w on this side. 420 divided by 6, you are getting 70 as your width. That's 70 meters. It's a little m right there. So your width is 70 meters. Beautiful. Are you done? No, of course not. It's a word problem. You have to go back and read it again. So the question here is, find the length of the parking lot. Find the length. We found the width, which means we need to take this value and plug it in to solve for the length. So the length, I'm going to use this side right here. The length is 2w minus 10. We were already told that value. We know the width is 70 meters, so the length is 2 times 70 minus 10. Now, I can simplify. So that's 140 minus 10, or 130 meters. Question. It said, find the length of the parking lot. Are we done? Yes, we found the length of the parking lot. As you can see, our strategies that we've talked about so far throughout the course have been really building on each other. So you're always building throughout math. You're still embedding these reading strategies as you're going through, especially on word problems. Okay, let's do another problem, which of course means I need board space. Good. All right, the last problem for section 2.5 says convert 77 degrees Fahrenheit to its equivalent temperature in degrees Celsius. Notice it doesn't give you a formula or anything right here in the problem. Now, if you don't know the Fahrenheit Celsius conversion, at the very top of your page, you do have that formula available. I'm going to go ahead and write it up here. So I know that my Fahrenheit F is equal to 9/5 of my Celsius C plus 32. Good. Now it says convert 77 degrees Fahrenheit to its equivalent temperature in degrees Celsius. Okay, so we know Fahrenheit is 77 degrees. Great. So there are a couple different ways that you can go through and solve this problem. I'm going to take the one that's probably most obvious to everybody who's watching. Though, again, a couple different ways that you can do this. So I'm going to take the 77 and I'm just going to plug it in. Why not? You have a value, so you absolutely can do this. So I have 77 degrees is equal to 9/5 C plus 32. Notice we're just talking about a one variable equation at this point. So I can subtract my 32 over. So 77 minus your 32, you get 45. This is equal to 9/5 C. Now you may be saying, well, wait a minute, why didn't you clear the fractions first? You told us to do that before. You're absolutely right. However, what I'm looking at in this problem is that I had pretty simple values right here, the 77 and the 32, that I could easily just move that 32 over, make my life a little bit easier, fewer things that I actually have to multiply or divide. And so what we're going to do at this point is look and see what we have. I have 45 and I have a 9/5. This 9/5 could easily be multiplied out so that you clear the fraction, or because you only have one part on either side, this might be easier. Multiply by the reciprocal. So whenever you're dividing fractions from one side to the other, you multiply by the reciprocal. And the reciprocal is simply take that fraction and flip it. That's all you're doing. You're reciprocating. What you do to one side, of course, make sure you do to both sides. There is a method to my madness here. So this side goes to C. That is a C, just to be very clear. Now this side, let's talk about it. Yes, you could take 5 and multiply it by 45, get a very large number, and then you would divide out by 9. Absolutely, you can do that, and I'm not going to stop you if that's what you want to do. You can also punch it into a calculator. That's perfectly fine too. Just make sure it calculates correctly. Now, here's the kicker. 9 can actually go into 45. How many times? 5 times. So 9 can go into 45 5 times, which means what I have in reality here is 5 times 5, or 25. And so this is talking about temperature, so that is 25 degrees. Since it was a word problem, go back. Convert 77 degrees Fahrenheit to its equivalent temperature in degrees Celsius. Did we do that? Yes. Yes, we did. Okay, thank you guys. That is it for section 2.5. I will continue with the next lecture in just a few moments.